Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about rocket science. So let's dive right into it. Now, I'm talking about the overall picture that humanity has a whole of this technology, so to say. So there is a very serious amount of prestige involved into this. Now, we all of us hold rocket science as one of the most complex science but trust me, there are many other branches of science that will make this look like a child's play. And you can see that even in our language, we say it's not rocket science, meaning if somebody is having trouble with something basic, menial, you will say, hey dude, this is not rocket science, come on, you can do it. So we are flat out using rocket science as one of the most complex things. And here's the thing you have to understand. Any time a person deals with rocket technology, even though they may be average in terms of intelligence, we always hold them to a higher standard, whereas like be it Elon Musk, be it APJ Abdul Kalam, be it Warner Braun, we always have a scenario where it's like, dude, if you are in working actual rocket science, you are like, cut above, quote unquote. So that creates a serious prestige aspect to it, and people want to follow that. And any nation, if it has good leadership, generally will pour money into this like there is no tomorrow. Now of course each country is limited by its GDP, so do not expect Nepal to pour as much money as India does, and India to pour as much as NASA does, but they will try to do their best to get blank check, meaning go YOLO on it. And there is an actual benefit to it, meaning if you truly push humans, want to push human beyond our limitation at this point in time is that we are all stuck in one goddamn planet. And that's okay, but that's okay for an animal, that's not okay for humans. It's like, what's the difference between human and animal? If both of them are like born on this planet, both of them die in this planet, I'm talking overall, then what's the point? But again, take off is this way. Let's say we go to moon and we start to grow there, have a self-sustaining colony. We go to Mars, have a self-sustaining colony. Over time, we start to grow, truly grow, as in like Earth will become just one of the option. Let's say there are like multiple large habitats. There are many things we can do. Then we can grow amongst the star. There is a reason, a scientific reason why we say space is the final frontier. So to really push humanity beyond its cradle limits, we need to have this sort of system. That's why this prestige is not unearned. It's like there is a reason for it. So why this is so complex? Well, mathematics. That's the true complexity of it. You may think it's the engineering part of it. Well, it is. It's not a walk in the park, quote unquote, but it is not that hard. That hard part is the math. The math of this puppy is ludicrously complex, meaning what we call brain melting orbital mechanics. It's inherently complex, and it's inherently counterintuitive, meaning you'll think, oh, like going to the sun will be super easy. You throw things at, nah bro, if you do that you will miss sun. It's like, what? Yeah, that happens. The orbital mechanics is literally counterintuitive to every sense. Now, what do we actually figure out when you are studying this sort of technology and mathematics? You are studying what we call orbits and delta V. That's all there is to it at the end of the day. How you are making your orbit from circular to elliptical, elliptical to transfer, whatever have you. At the end of the day, it's all about the studies of orbits and delta V, meaning how much energy you have to put. And you have to be good at math, because I don't even know why this is classified as math, because it looks like gibberish to me. But that's the reality of it. Again, I'm dumb, but you get that point. Like, you have to be able to solve something like this, or even more complex variants of that is now utilized by supercomputers to calculate most optimized trajectories. So it is ludicrously. However, that being said, you have to understand a human brain is kind of capable devices, because anytime we are trying to make artificial intelligence drive a car, we are realizing that it's just stuck. Here's the deal. You do not know how far the next car is when you're driving. You do not know that. You cannot tell, oh, it's 3.4 meters away. You don't know that. But then how the heck you drive? You drive in a vague sense. So as in like, that car is far enough that I can apply the brake and car will stop. And that is a rough estimate. And there you have 10,000s of this rough estimate. Based on that, you are just driving. So if you want to get that rough estimate of orbital mechanics, meaning so it will no longer feel counterintuitive, I would urge you to play games like Kerbal Space Program. And we're like, oh, this is just a game. It is a time wasting. Yes, deal. If you give this technology to NASA in 1960, they will reach Mars. So it's a seriously complex, and it will remove one of the psychological barrier of understanding. It's like nobody can troll you after that. You're like, I get it, and you will hate sci-fi after that, because many sci-fi artists, they just even expands. In one point, I will make a detailed video about that. It really pisses me off. It's like, dude, did you break light speed in this? But you get that point. So the math is the main core aspect of it. It's like this hulululu starts to make sense to you in order to you truly do the orbital mathematics aspect of it. So that's the thing that is the most frightening to the people. Then we come to engineering. Now again, even though math is more complex, this is on a whole different level in terms of engineering, something that we can feel. It's not something on paper, it's something that you touch, hold. And why is such a big deal? Well, the wide temperature range, meaning you can have liquid hydrogen chilling, chilling at minus 251 degrees Celsius, meaning chilling really close to absolute zero. And then you can have fire going at 3200 degrees Celsius, meaning there is no metal known to man that can survive that temperature. It's like, then how the heck you have the engine? That's the engineering part of it. That's the part that makes it so frustrating. Now you may say, isn't fusion reactor much higher than that? Because again, it also goes to this cryogenic temperature and has like 15 million degrees Celsius. Yes and no. Yes, it does go to 15 million degrees Celsius, but the reason why it does not melt the chamber is simply because it's not touching it. It's magnetically confined. Here, there is no confinement. It's touching, baby. It's touching all the way. So it is tangibly brutal. And you have to make it as light as possible. That creates another hassle. Now you may be like, okay, it has to handle some large temperature variation. It has to be light as possible. That's good enough? No, it also has to be strong. How strong? It has to be able to stand some shocks and vibration. This is one thing that fighter jet engineers have to deal with a lot. Meaning you may be like, okay, I'm going to give this engine that is super badass, powerful, awesome, no problem. I'm going to, give the avionics package and control computers and control surfaces that can do very high G-turn. Here's the deal. If the computer actually executed that, and if your plane is not stronger, you do this, your wings will fall apart. And it has actually happened. It has actually happened to many aircrafts where they're like doing basic turn. Either the metal was fatigued or like too old, MiG-21s, or you had a scenario where it's like, the metal fatigued. And again, if you want to push the G-force capacity of the craft, you have to design it that way so it can endure it. Otherwise, it will simply not simply fall apart on its own, which, mind you, has happened. Surprisingly large amount of plane has fallen apart because of this. So you have to be strong against shocks and vibration, because this engine, they are powerful, boy, meaning they literally shake the ground. That's how powerful they are. Like when Saturn V was launched, it's literally created a miniature earthquake which was detected on Richter scale throughout the planet. Basically, on that continental shift was starting to like vibrate. Again, it was not the buildings were shaking, but it was like, Richter scales were, I can see something doing something. So these are very strong vibrations. And in terms of when it's pushing through max Q, it's really brutal on it. On top of that, it has to be smart and agile. Smart as in, like, it has to know things. It has to understand, like, where is my center of gravity? Well, now, like, why the heck that would change? Again, it's just a flying fuel tank. It's changing, liquid is changing, so it has to counteract that. And it has to work in such a way where it's like, I know what's happening, how things are changing. Because again, if it pulls throttle all the time, it will self-destruct the moment it goes through max Q. So it has to throttle down. It's like, relax, bro, relax. Chill, take some chill pill. It has to be smart and it has to be agile, because there is a launch corridor, and the moment rocket goes away from the launch corridor, it says boom. Again, it's a safety function, so launch corridor is also designed so it has to auto correct it. Be mindful, there is no external guidance, there is nobody driving it like this. It's just the avionics in it is doing the job. So it is tangibly complex engineering. Now, all those things that I said, many of you would have agreed with that. Like, yeah, it's complex engineering. Yeah, it is ludicrously complex math. But it creates a paradox. Now, that paradox is that this public perception of this, like, rocket science being so complex, stops normal people from achieving, going into this field. Now, I'm talking about the top 1%. They will do whatever the hell they want to do. They have that kind of drive, that brute force, power of will, where they're like, dude, I want to achieve this. I'm going to do it, the end. Is the question with them is like, who is going to stop them? It's like, you can't do that. Is to like, who is going to stop you? So they're going to do it. But here's the, you do not run a nation on 1%, you run a nation on 99%. So that large group of people, even if they are really good enough, if they are like good enough, they're actually good enough, they will simply not pursue it simply because of that perception, because it's heavy. And many kids who want to, like, I want to build Starship, I want to build rocket, and I want to go to Mars too, like, I want to go to moon. It's like they will simply give up on this. And that happens because of this perception that is around it, and this creates a very dark side effect. That side effect is it creates a very long stagnation period. Now, stagnation period is basically old technology, meaning something that has been achieved in 1970 will be treated as like, oh, this is untouchable black magic and hululu technology. It's like, India is still using 1970s rockets. It's like everybody's treating like, wow, it's like it's a workhorse rocket. It's like, Soviets, 100-year-old design. Again, it's not that 100 years old, but you get that point. It's like every old technology starts to become like, how is this magical thing? It's like, dude, it's 1970s technology. We have 10,000 times better technology now. But nobody does that, because the amount of people that you need to send into this field to grow it properly, it's not happening. Because here's the deal. What is the ultimate resource of a country? It's people. It's nothing else, just people. So if you do not, get stuck into that paradox, you have a scenario where you can literally spend time, money, effort, everything over decades, and you will have no progression, meaning you will still be using 1970s rocket into 2030s. So that creates a very serious scenario. Now it has to change. Be very mindful. If you look at each nation state, you could have a scenario where it's like one nation is stuck. Let's say India is stuck, UK stuck, European Union stuck. No problem. Here's the deal. Not everybody would be stuck. Somebody in America would be like, you know what if we don't do this? What if we unstuck ourselves? What if we break this paradox? What if we allow common people to get into it? Like, hey, bro, try it. Like, bro, you know how to make fuel tanks? Good. GG. You have worked in LNG industry? Good. We will. I don't care whether you have not worked in rocket industry. Have you worked with LNGs? Okay, awesome. Come design this tank. And these are the characteristics. They will work. They will grow. And here's the deal. If this was done in 1970s, that means we can do it today also. And that's what happened. So people who are changing, they are progressing, and people who are not changing, they are getting bit slapped. Meaning, you can literally have a nation that has spent money like there is no tomorrow, and put the brightest mind a nation has, can get bitch slapped by someone who is like barely 18 to 22 years old. That's the whole thing. And it happens to every country. That's why this paradox is very brutal. You have to replace the people that are there. And like, again, periodically, and it has to be like, more and more new people are coming in, more and more new ideas are brought into this fold, quote unquote. And one of the very important aspect is cross-pollination, meaning just because you are working on a rocketry industry does not mean every person working there has to be from rocket engineering. And this is one of the amazing aspect of Elon Musk. That's the one thing that he figured out, because he came from software background. He was already like, the black sheep, quote unquote. So he already had that understanding where it's like, dude, I don't need someone who's like, directly from this. He's like, hey, dude, have you worked with metals? Have you worked with this? I think, you are qualified. Like, there are people who are working with burners. There are people working with jet engine. They're like, dude, more or less the same thing. How about you try to make a jet engine? How about you try to make a rocket engine? It's like, not that difficult. Let me try. And again, the moment somebody says, let me try, they generally solve it. So that's why you can have small companies that have like no experience, nothing, just bitch slapping the whole NASA and like ISRO and all that jazz. It's like, bro, it's like, I will land 100 rockets. You will have a hard time launching 100 rockets. So that's the paradox of it. Because of this perception, enough normal people do not go into this. You do not have enough cross-pollination, and that creates a stagnation, which is really brutal for any nation. The moment a nation gets stuck into this, it's might as well game over for them, because it is a race. At the end of the day, it is a race. You cannot, stagnate your way to victory, so to say. And there is a one cruel upper limit to this, because it's a dangerous technology, meaning if there is a failure in your system, you can hit anything anywhere on this planet. Meaning, you can literally have a scenario, hey, I launched a rocket from India and it could hit basically the payload. And let's say you design the payload for recovery and it has the heat shield. You can literally hit something like Three Gorges Dam in China or Hoover Dam in USA. It could happen. So it is one of those things that is something taken very seriously. You cannot just let anyone who can build it. They have to have understanding of ethics, understanding of consequences, understand like, hey, we have launch corridor. How about we actually blow up our rocket if it veers off from the launch cars? Again, trust me when I say this, people did not used to do that in the early days. They were just like, again, they were trying. Now we know like we have to have it. So this is one thing you have to understand, and this is more about human perception, human psychology, rather than like fault of the science or something like that. Because the first thing we built was ICBM, interconstellar ballistic boom stuff, and then we took hey, instead of doing boom, what if we whoosh it? Like literally, we had ICBM, we just stripped it down to make it into a rocket system. And that's very real. That's why every other country fears every other country that's developing rocket technology. When he was like, dude, they are developing rocket, and you're like, why the heck your own country may be freaking out? Simply because they know for a fact that if I were doing it, I would be making ICBM first, disguised as commercial rocket projects. So that's why there is a fear that is legitimate, because it is a dangerous technology. While ICBMs have what we classify as ballistic trajectory, so they have limits, meaning how far they can actually hit. When you're talking about orbital class technology, side effect is slower, benefit anywhere on the planet. So, and that is something tangible. That is not something that you can just YOLO it. That's why no nation will just let you YOLO it. Even if you have boatload of money, even if you have boatload of brain power and you have good intentions, countries around the world will not just let you go YOLO on it. And the darkest side of it is that if your government is slow, because more and more countries are realizing that, dude, this lockdown attitude, again, you can keep it locked down. You can be like, hey, I do not have to deal with the paperwork and all. That's awesome. That's awesome. That's GG. Here's the deal. You will be stagnated and out of the race So more and more countries are realizing that, you know what, that's not sustainable in the long run. People will start, like brightest of your people will simply start to leave your country. Now, why did USA started it? Again, they had a scenario. How do I put this properly? Mine's bigger than yours. They actually have the bigger than yours. So they had the scenario where even if an incident happened, they like flat out they can go to anyone, and they just like, you know, again, they had experience, they had the risk taking ability, you know, America, F yeah. So they tried it, and then it started to bear fruit. Looking at that fruits of that labor, people are like, you know what, we would love to have our own electron rocket, we would love to have our, like, you know, this and that and all that jazz. So all other countries, be it UK, be it Roscosmos, be it NASA, be it JAXA, be it ESA, ISRO, DLR, almost everybody is looking seriously into this, simply because USA took a risk on commercial systems and it paid off, and now everybody is like, ah, damn. Like, you can have a multi-million-dollar rocket that is like, you know, it's like meticulously built with like some smartest people, but it's like, dude, it's hyper expensive, hyper slow, and hyper low capability, and you can't even launch this puppy, like, you know, 5 times a year. So that's the whole reality of it. That's the whole stagnant aspect of it, where people will think like, you know, this ancient technology is like, you, it is the latest and greatest. That's the one thing that we have to understand. And limit is really brutal for children, simply because if they genuinely want to, and if they genuinely have the intellect, it's far better for them to like leave their country, go to other country, get the citizenship, you know, clear all the exams, get into their space program, become an astronaut, actually go to space, and then come back. And then they will notice their country has still not progressed. Has happened to enough Indian astronauts that I know this. So there are some serious limitation to this. So this part you can't solve. This part you can't. Other part you can solve, but this part you can't really solve. So that's the dark side of it. So this was my presentation on rocket science. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.